Good morning, everybody.
Good morning.
Good morning.
Great day, but this is the second session. You are going to start, right?
Yeah, I'm gonna start soon.
Okay, okay. Yeah, please give 1 minute if somebody joins. Okay, Dev. So go ahead and you start your presentation.
Alright, so welcome to part two of this small amendment. Here's our agenda for today. We are following up on this IE1 project. We're starting off with hydrology. I'm going to be showing you the best way to do hydrology is to do drawing the land uses, the soils, and then how to do TT passing calculation. And after those three are complete, I'm going to show you how to utilize the drainage area tool in microtation. And then I'm going to show you how to import it into your 55. Okay, and then after all that is set up, the next thing on the agenda will be how to set up the water quality drawing and calculation and microtation and how to draw them, and also how to input those numbers into the PRD software management spreadsheet as well to get your ESDV required and IR required. IR IR means impoverished area that requires treatment. Okay, okay, so let's get started. So first and first is land users. You need to create a new folder, a new file that called MRUE for just a land use and MRU-P for proposed. So right now I'm in my existing land use file. Okay. Now previously I stated that you know, in order to figure out the drainage areas, we need to figure out what our POIs are. And you see, you know up here why you're like outside the roads here. Usually, like I said, POIs are usually where they leave the right of way. Uh, Let me see if I can show you what I mean by that. MRWE right of way. Like you see here, it's on the right of way. Yeah. Most of my POIs are located outside where it leads where the flow of water leads the right of way. Okay. Now I'm not gonna go through how I delineated all these areas. This is something that you'll learn over the course of time when you get project by following the contours and everything. So it's just basically, the high point where it splits with the water flows. Okay. Okay, so for land uses, we need to have our drainage area in here, just so we can get like a good overall section of it. And so when you first started, we usually don't have surveys. So how we do land uses? So as you can see, I have the area on in here, and you can reference your area by going to the toolbar here, going to attach area imagery and system imagery, and now you can turn on the area in here. Okay. Now, before you start any project, it's important that you realize that we do have resources to help you guys. Okay? Sometimes I know people draw like roadways manually and everything. But first thing is that you want to shut the library. You see, if we already have the aerial in here for road, so we want to so let's go check. So we know this in Washington County. So we want to go to our library or project and go to details. And these are the details we have on file. Uh, now we'll go to look out see statewide GIS. Now it's just like what we have different counties here, okay? And it's been collecting for a lot of years. Every time we download something, we dump it in here. So we know this is our Washington County. Let's see. Yeah, Southern Line building address for. So, but let's check out the plain mystery. See, we have a lot of these DGNs here. So let's see. Okay, I see we have roads here, which we will need to do for the impervious. So let's see if I can reference in this road here. Park BC. Go into detail. Uh, Washington County, payment fee, and road. Let's see. This will help speed things up so you don't have to draw things in. So no nothing. Let's see. I don't see anything here. I can find the so then we can go back and open this in 2 seconds. Because there might be a couple of layers that's not turned off or turned on. Yeah, some roads here, some roads here. But it's not, it doesn't have like the main road. Wow. We can check it by going to the forest though. So it's just, it may be time consuming, but it's better off than going back and wasting your time. Okay, so now we know. Okay, so now we know this is the right file. So so it's better to your check and see. But no, we know we don't have it. So this means that most of the time we have to do it by hand with the roadway. So for now, I'm just gonna do this one strange area. So basically, what I'll do is I'll just open up my land use file, file menu, joint land use model, and then this is the road. So I'll just do probably maybe open session. And then I'll just like draw, like maybe I'll just estimate like here, so and again for concept, this is very conservative here for concept. But once you get surveyed, you can get very specific on survey. Once you have this area selected, I see that like a public here. No, exactly. And then now I can do the shape method to just fill it in quickly. Toolbar. I just flat method, impervious area, pave road, open section. Now these open section, closed section means there's curb. Open section means there's no curb. And then let's see, urban, open space, no, impervious area, open section. Now here I can do by flood. On my check, locate show your shapes. Yeah, so see what happened. I can ignore until your shapes. Look into your type dynamic area. So let's just do ignore until your shape. Okay, now you see what happened? It stops here. That's because you have a line here, which is kind of off. So, but I don't want to do that, you know. I want the whole thing. So it just makes it easier. So I'll turn off this level. And now I do Pivot to open. Not clicking on it. Now it's nothing's hosting here. That's just hosting here. And it's just a hosting here. Okay. Now usually inside inside the right of way, the for glass and everything, it's usually considered open space. Here, open space. But anything that's outside the right of way, it could be considered like depending on what it looks like. Could consider this might be like row crop or very dense grass. But then once it, the way to check is just go to Google Maps just to make sure you might be able to put your person. No, okay, now it's open, but here it seems like this. It's like cropped farm area. So now that we got that settled, we can do open space up to the right of way. It's a good open space here, open space here. Now let's see. Let's go back to the start here. Let's see. This is glass. So I'm gonna safely assume that some the right of way it might be here. But but if you want to check if there's a right of way here, we do have files for it in the detail folder. So let's check and see if we have right of way in the folder detail. Let's just say right of way folder. Now we have different counties here. We're in Washington County, so we go Washington County. Open. Gosh. Okay, now we have this right. So this is the right of way here. So now I can go in and draw my urban open space. Now I want to turn this off. Now anything after that, I'm assuming that it's gonna be like farmland or row crop. So I'm just gonna turn off on this and then go to urban agriculture. You see a pasture, meadow, brush, wood, farmstead. Well, I believe it should be row crop, which is undercultivated. Row crop, which is straight good. It might be able to just go here. Here, okay. Um, So now, so that's your land use for this specific area. Okay. Um. So now that we have the land use for that, and if you remember, we already downloaded the soil map for this. So now on the next agenda, next on the agenda is to CT path and calculations and transfer tool. So now we got this land use set for this POI here. I want to save it. Save settings. Exit out of it. And now I want to open up my drainage area model file. On want to pull up my MDE. So before I get into the time of concentration stuff, let me show you how to get all the information you need in order to put it in a TR-55 or AutoCAD area. Okay. So this joining tool that we have here, you know. So if you go to, if you open up your TR-55, which should be an engineering application, one TR-55, and now as you can see, you notice, yeah, the stub area drain name below the color. You have areas and acres. So if you click on this here, you'll see all these details for land use. This is where you put the land use in, okay? Um, so it's usually in acres. So let me reference in my MLE. Now we have the MLE here, but we need to figure out what shore it's in, whether it's A, B, C, or D. Each shore has a different um rate of and what's the name? Different rate of permeability or uh And the infiltration rate. Each shore has different infiltration rates. A and B shore are usually with well infiltrated, and C and D shore when there's very like almost no infiltration rate. What that means is it's like when it rains, water is going through the soil. And so I want to open up my shore map. Okay, so this is my shore that we have here. You see, I have these are D shore and this is B shore. Okay. You have two different shores. So before I started, you know, I was doing the areas by hand, right? But that was like when I was a young lad, okay? And so, but it was tough to do it by hand because you have to know, okay, this is meadow and this is in B shores. And you have to figure out what's the area by measure area and do it by flood and acre. You have to like locate interior shapes. You know, then then you measure and put into the office by. You know, you have to do this, know this in these stores. But there's a much easier way to do this. A much faster and efficient way, which is utilizing your drainage area tool here, which is you got manage drainage area, default, and then you can analyze. No, right now it's in square feet, but we want in acres, so we're gonna do acres with a position of 2. Okay. Now you have to be careful. Now I'm scanning this. Now you scan it. It has it basically comes out with all the area that you have here, which is a total of 16 areas. Okay? But we just want this area here, right? So if you were able to click on this, it will highlight the areas. That, now I found it for this one here. Now, now you have to be careful though. If this drainage area is on a different level, so let's say, okay, I'll remove this. Let's say from this. So let's say if I change this level to just a random at default, and I reset it, and I analyze it, and I scan, I only now have 15 drainage areas. The reason why because it's not on the right level. So if I change this level back, and the way to change it is just to make sure you can utilize the tools here. To click delineation, drainage area, it will automatically apply it. Then I click scan again, and I have it here. So make sure it's on the correct level for because everything is connected with the M.HA database. Mm. So, so I have all the areas, but no, I don't want to do all these areas here. So really, I can probably just remove it from my database for now. Just click remove drainage area from my tools. And if you have like multiple ones that you have to do for projects, what you can do is you can rename it and say POI -1 apply. Now we want to do our stores. I want to scan it, but there's no store. It says there's no store boundaries found. That's because my reference is off. So you have to have the reference on for both stores and land use. So if you scan it, it'll recognize the stores that you have. Okay. Now the next thing you do is you can compute the code number here. Uh, now you can spit it out, okay, as a report. So you can generate the report here. You can generate report, and then really you want to save it in your like hydraulics folder on the calculation and drainage, okay, and then your shell will automatically spit it out. Now these numbers should be matching. Which if it's not matching, that means there's something wrong with your land use. You have some gaps in there. Everything. So now that you spit out this Excel, but I want to simplify it so it's easier for me to put into TR55. So what I do? So what you do is I do a total. I make sure I have my total here, and then I do a sum, and then okay, I know this should be. I know impervious area D. So maybe I do for some all the impervious area in D so like 1.34. And I delete it. B, there's only one. Then D shore for open space. I do for the sum of all the D shore that we have, And I do 2.7. Delete my open space. And then boom, vocal. And then now that I've simplified everything, I can just input it into my PR55. So you want to do your sub area name to POI 1, then area 2, POI 1, and then you want already to outlet an area. You just plug and chug, you know. The public areas that can be sold 104. The public area that can be sold 1.4. 4. Good condition, open space, 0.94. I'm careful, 1.44. And then D, shore, open space, 7. And then you have row crop, cultivated agriculture, straight row, 5.15, and 1.1, and then twist a stop. So that's how you do see all 65. But then you want to check your storm data source. The typical storm data source would be like NOAA type C. And you can change it by going to your storm data, and change it to NOAA type C. But here it says this is for Howard County. So I want to change it to Washington County. Washington County, NOAA. So Washington County doesn't have any NOAA C. So you're going to choose the default. NOAA B. Then storm data type 2. Then if you watch each number, it will change it to the to these numbers. And then you click accept. So that's how you do that. And then the time of concentration. So that's a very easy way to do drainage areas. So you can have multiple drainage areas as you want. You can scan it again. You can rename them as POI2. Apply. Your code number. If you generate a report again, but this time I won't save on my desktop, just so you know. Can't open two workbooks with the same name. Okay. I'm gonna save it. Yeah. Okay. So it's always showing POI1 because that's all the land use that I have here. We didn't do any of the rest of the land use. So let's just do this then. I'll test the land use I made already for this whole entire project. And then I'll scan again. Few code number. And generate up my report. Now you have already here. So it's just a very quick way to generate your hydrology joint area. Alright, now let's go to Now in TR55, you have something called time of concentration here. Now TR55, it'll give you the flow type of time of concentration here. You have sea flow, shadow concentrated, and then you have the total. Now, I'm not gonna go over it too deeply, but if you want to know more about time of concentration, our method, in terms of calculation, you can always use there's a manual here that you can study and go through. And let's see, there's in the resources, CR55, and then a manual. Let's explain about CR55 and how to use CR55. You have SOC 3, concentration. Now, now, for the first portion of this area here, I want to turn on my thermal concentration. Let me turn on my land use. Now let's just focus on this area here. So you wanna turn on the contour. So it's usually you start the thermal concentration from the furthest point of the drainage area or the highest point of the drainage area. So you can see here, this this contour is at a high point here at 650, and then it just goes down. So you start time concentration here. Go from A to B. So sheet flow is usually A to B. It's usually start um your time concentration. Now the your manual says that the maximum time of concentration for sheet flow is 300 feet, but in Maryland they like to use the maximum common concentration to be 100 feet for sheet flow. So then what you want to do is you want to go to your TR55, the sheet flow 100 feet. You want to calculate the slope. So I would measure 100 feet and then take the elevation here, 650. No, it's in between here. So what's this elevation? 643. I mean 644. Or 640. So 650 minus 644 is 6 feet. So it's just about 108.0 check, right? So you just do 0.0 to in the minute, and what you can find in as well in the handbook here in the for sheet flow, a glass, but a TRC file they'll provide it for you here. Smooth surface is for roads, cultivated like low class, no, resin, shortened. So here, let's let's put my vocal. So we know that this is vocal ops. I want to shift my sequence so that this is in the front. This is vocal ops, so here I want to vocal ops. And then after chief flow, it's always shallow, concentrated flow. Then I just want to go in my drainage area, shallow, concentrated flow. Yeah. Now I'll just do a measure distance. I'll do a long element. Circle to here. 427. And then I try, this is 644. And then this is 630. Yeah. So it's like 8 feet divided by, what is it, 422, right? 427. It'll be payable, unpaid for $3 paid. Yeah. But then you have, okay, from here to here, there's a pipe here, maybe? And so, in order to do the pipe, it'll be considered like a channel, kind of. So, if you go to your 55, you have channel, you have a length and flow, then they have the end value area and the velocity. So, so for now, I have a resource um that can figure out all the areas and what the perimeter for you. So let's just say if this is from C to E, C D or C to E, this is a 50-inch pipe. So let's just say this is measure it. This is 15-inch pipe, 179 feet. 179. I'm gonna assume a slope of 1%, no standard for pipe. And I'm gonna assume that this is a concrete pipe, which has the end value of 0.013. Now, how do we get the area? What is permanent velocity? So I have a spreadsheet here. Mm, where is it? I have a spreadsheet, hydraulic calculation. Okay. I have a teaching competition first year. Now, I use this spreadsheet in case we have like a very big drainage area and we have a lot of points for time concentration. It allows me to split it up even more. I see on 55 you're very limited. You can't really add any more to it. So sometimes I let you go here and you can. And so let's say, okay, you have a pipe here. Let's assume this is a 15-inch pipe. I'm assuming a depth of 1 feet, which is like your water depth channel flow, and then I'm calculate your square footage by an equation. So you just got to put this area here 1.23, the water perimeter 3.9, and they'll calculate your velocity for you and your flow. Now, after the pipe, it goes into a channel. Now you have to remember that once you go from shallow concentrated to a channel, you cannot go back to concentrated flow. It has to be a channel for the remainder of the time. So now this is concept, I'm gonna assume that I'm gonna assume the velocity for the channel here. But this is channel length. And then the slope, I'm assuming it's very flat. No, 0.05, 0.02. And I'm going to assume a velocity of 4 feet per second, just to be very conservative. And click accept. So now you have all the information in your TLC file. You can run it to get your 2-year flow, 10-year flow, 100-year, 25-year, or 1 year. And you run it. It'll give you the flow to the POI, 2-year, 10-year, etc. So that's just the basic of how to do the hydraulics for a drainage area. Okay. Now, now that we have the existing um things done, we want usually after we do the existing drainage area, we go to the field and check it out and see if it's okay, matches, and we come back and anything that we need to revise, we do revise it. Um, okay. So, the next thing to do is by this point, the highway should be finishing up, should be finished with the like design, you know. And this is, and at this point, is where we start the water quality drawing and calculation. Uh, what is it? Okay. Shit. What's on? I wasn't. So basically, just have to do the founding music again for the model, water quality, efficient. Uh, now you want to just in your water quality map, you want to attach the shading file, the MHD file, the drainage area, the existing drainage area. Okay. Okay. Let's change my code. So here's the shading file and the proposed highway design file. Okay. So for now, we're just gonna focus on this POI. Yeah, okay. Drawing our walk line. So you need the but by this time we should also have we should be having a survey. So you want to attach the survey. Maybe this is it. The ocean. I do not. Let me see where. Okay, so survey mapping. I think it should be. Listen. Okay, here's the survey. The survey should always be in the survey and mapping folder. Uh, so, so for me to be able to tell the difference, I I like to use a different color. See my override on. Just so it makes it easier for me to see what suggested and what proposed. Now I just want to focus on the roadway itself, like all these drawings. There we go. Okay. So I want to say this is as a fold or turn off. Okay, so let's make it thicker so you can easily see it. Okay, so now we know this. The red roll is my existence, and anything that's like in green should be proposed. Now, before you start your water, so now you have your water. Start your water quality stuff. You want to see what they're doing. Okay, so whenever you see like this patch pavement full, that means they're doing full depth passing, full depth on pavement. So for now, this is existing. So whenever they're doing full depth inside existing, that should be considered redevelopment or reconstruction. Now anything that's outside of it, that's outside the existing road, this should be considered as new impervious. Okay. So the best way to do that is okay. Okay, and this is just overlay milling. We don't really need to do anything about that. They're not like going in and ripping things out when it's overlay milling. So we'll just have to focus on the shading for the full depth and things like that. And now I want to go to my water quality map, water quality model, and create shape to do a buffer line. I want to do impervious redevelopment. And then where's my oh create shape impervious. Missing my toolbar here. There we go. So I want to make sure I fill type propane. Sorry. Yeah. I just click on it. Now that and it's automatically selecting the whole thing. Yeah. All the way to the end. So now I want to do okay. This is new impervious, right? I want to create shape into new impervious. Let's do non-opaque, original, and then focus on selecting this area. I want to make sure, okay, finishing here. So, so now you have your reconstructed and your new impervious in this POI1. Now that we have this, you want to start implementing it in your PRDs spreadsheet in order to figure out how much ESDV that you need requires and impervious air that requires treatment. But before you do that, you you have to make sure you have an LD in you, which is located in the MBS usually. No, that's in okay. It's the LD here. Okay. So now that we have all this set, I just want my LD. Okay, I don't want anything else in this. Just my LD. That's all I want. Okay, now that we have this POI one water quality model set, I want to open up my PRD spreadsheet for calculating. So investment, which is cost. This is the cost of MDE score amendment calculator. Okay. Oh, where did it go? Alrighty. Now this PRD or MDE spreadsheet. Basically, you plug inside the existing condition, the proposed condition. So first of all, let's okay. First, let's do it. Right now, I'm focusing on just one POI. I'm gonna go to each column and tell you what it means. And also, I think I'm gonna share some resources as well that tells you about this PRD spreadsheet as well. So, to POI one, you wanna put the stormwater management study area. Okay? This area is usually bounded by your LOD. Okay. So in order to get this area, you need to get your POI right here in the area inside that POI, which is bounded by the LOD. What I mean by that is you go to the, you know, let me. So you need the area that's bounded. They're talking about this whole area here, which is bounded by the LOD. So I want to measure area. You can do it by flood. I want this area. No. Let me turn this off. So I'm gonna do the area, make an area. They found it here. So I found it here. Look into it. It's 38. That's 3,000 square feet. But I want it to be acres. You know, sometimes you measure area tool, it might not fit like the acres tool. No, I find that sometimes you may have to close it out and open up again in order for it to show the acres tool. But for now, let's just do the there in 1 acre there's 43,560 square feet, right? So to 388 when I divide by 43,560. That's 0.89 acres. So I'm gonna go to my school. And I'm just gonna put, 0.89 acres. And then I'm gonna do my existing impervious surface area, which is typically your reconstructed area. Okay? So I'm gonna turn on this area here. Now, now you don't have to like click on it to get the area. There's also a tool that you can use. We have tools here for impervious counting. You should scan removal, ingestion, new impervious, redevelopment, or reconstructed in water quality law. So we want redevelopment. Let's scan it. See why is it not. See redevelopment in new impervious. There might be an issue here. So why is not complex shape? So it's accounting. Sometimes might work, sometimes it doesn't. After looking to it, sometimes it work. Alright, but for now, we'll just measure it. My flood, 982, 102. Then you have your percentage, you have your development, reconstruction, new development. Now the rule of thumb is for redevelopment and new development. If if your percent impervious is less than 40%, it's considered new development. If it's greater than 40%, let's say, let's say 0.5, it's considered redevelopment. So what's the difference between new development and redevelopment? It all depends on your impervious area that you're treating. So typically for projects or sites that's a new development, you have to treat 100% of the impervious area that is being included, like new impervious, 100%. But for redevelopment, it's usually you only have to treat 50% of the new impervious area. Okay. So you can see here, so here's an example. So I have, this is 12.08 with my existing drainage area and my proposed drainage area. And what we got from CR 55, basically. And then my existing impervious area within the LD should be the same as this section here, so it should be 0.02. And my proposed impervious area within the LD is my new impervious area. And I take that, measure it, I flood, 5.95, which is 5.5, number 43 by 60. It's 0.13, 0.13. It's so now, because it's new development, okay, and you have a proposed impervious area within the area of 0.13. So that means if new development, you have to treat 100% of this new development here, which is 0.13. But if I were to change this, say 0.40, redevelopment, um, say 0.12, wait, a little bit less. Something off here. Okay, so this should be the impervious area for the all the impervious area. Okay, so if you're injecting in 0.02 and you have 0.13 new impervious, so this should be 0.15. Okay, this is 100%. These numbers are typically like 0. And for this column, we may have to cover that a little bit later in our next session. For sure, it gets pretty complicated. So now we have this set up. We have this I ought to be treated 0.15. And as you go down to this on spreadsheet, you have no you have no value here, which is required EXT volume for treating new development. Alright. And so you have to determine, okay, this new development here, what soil is it in? D soil, C soil, B soil, and A soil. So let's go back to make sure, and let's put in, let's add our soil map. back in there. So it seems like it's all detailed. It's, it's detailed here. I tell you what they okay. This has to be equal for the amount of the impervious energy they have. And so that means the total ESD that's required to be treated volume is 1,035 cubic feet. And the total IR impervious air quantity is 0.15 cubic feet. So what does this mean? So this means, which we'll cover in next week's session, this means that we have to provide stormwater management that can treat this amount of ions and this amount of volume, which I will show you next week. We have to like design a bioswale, micropolitan, glasswell, etc. Things like that. Mm. So this is that PRC spreadsheet for someone member calculation. Alright, now you can find this spreadsheet in our library or in the project folder. If you go to projects under engineering resources, I believe PRD. No, not this. Stormwater management spreadsheet. Yeah. And stormwater management calculation. All these spreadsheets. Yeah. Okay. Now, let's see what's on the agenda today. PRD. Okay. Alright. So that's basically how you do the water quality drawing. You reference in your survey and your MHD, and that's how you draw it. Let's do another example here. Trading file. Let's do this one here. So typically for this one, when the highway gives you a shading file and it has this here, this is called removal. It basically means they're removing this section. Now you can just do create shape, impervious removal, and it was you just select it. Until that removal, select. This is now this one is removal, but no, it's not like a full thing here. So one thing you can do is one thing you can probably do is you could ask highway for them to make like a full chase, so that it make it easier for you to fill in. or a hash. It seems like it's not like an official tape here. But one thing that you can do is until your tapes. I don't know. Now, one thing you might be able to do is if you highlight all this stuff here, and then you can do region for your tag. You can create region, but you can do like a union. Don't keep original. And now it's like all one shape. Okay. Uh. Okay. So. That's, okay. Oh. So here, I'm on there are a couple more spreadsheets that we can use here for filling out, which is the water quality summary sheet and it's just a water quality summary sheet. So what we can do is go to here. Here is the water quality summary sheet. This is the basic version of the water quality summary sheet. So it's basically whenever you finish filling out the Stormwater management calculator, you can probably just put it in here. Because if you notice here, let's say, report to water quality summary sheet, column D, column B, C, E, F, which is this column. So you just do column BY1, impervious, and with an LD, 102. Column C, 115. Column D, 212. E0, F0, G0. And so all these numbers should the column should match the column I, which is 0, 0. Okay, we're good there. The column 2 should match column J. Column J, 1.5, 1.5, we're good. And then column K should match column K, 0, 1.5. And then next week we'll get into how to fill out this with proposed solar memory design, depending on what type of treatment you have for this. Uh, okay, so see, I want to see if I can do this shape. What if my tools are working? Yeah, yeah, sometimes I may have to edit out of this and then open it back up just to see if it'll work. My station is finicky like that. So sometimes you may have to close the file in order to use the tool. Let's see, let's see. They're working now. There we go. Now it's working. See that? So now scan this. Now scan the edition. So instead of like everything, you can just scan it. And then they'll give you like the entire thing. You change to a position here. Okay. But okay, so I want to go on one more thing with you. That'll be good when you have like multiple POIs and you're trying to figure out, okay, I want to know what's here on here, but I don't want to like click on every single one. So what you can do is, this is what you can do. If you want to separate it, reset it. So tools and previous accounting. So what you can do is you can create new models, okay? You can create a new model in here, just to say for property. You can copy this model here. And just say this for POI 2, which is this POI, okay? Okay. Now that you're in POI 2 here, you can just like delete this portion here, right? And then now you can run the impervious accounting thing again, new impervious, scan it. So now it's only taking this part here. And then you can just put it into your store management calculator for POI 2. For POI 2. So 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 if you have like multiple POIs and everything, you can let's say you have 16 POIs. You can create different models for each POI. And but what you want to do is you can have this model as a default model for everything. Okay. So the rule of thumb is to first first focus on doing the entire water quality map or song first for the entire project. And that will be your default water quality. And then in order to get the number to make it easier on yourself, you can split the POI into different models. And you can just use this tool to calculate how much you will need for this POI. Instead of like having to go, oh man, I have to mm, I have to find this area for this one here. Then I have to write it down. and then add it to figure out what the area is here and write it down. Or I could do like the dynamic area, and then I can click on control, and then control. It's just a hassle, right? Especially when it's a big area. So I find it easier and fast if you just, do the log party for the whole thing, and then split up the models based on the POIs, and just use this tool, and it'll scan everything for you. And then at the end, when you finish the whole thing for the reports and stuff, it'll give you this in the higher coverage area and assistant stuff like that you can use for the report. Because PRD is a huge stickler for numbers and making sure the numbers match. So if you do it right the first time, you don't have to go back over and do it again. All right. I think that should be a good stopping point for this session. So all in all, we cover all these and we cover hydrology, languages, TC path, genetic area tool, and TR 55. We didn't get into hydrocare yet, but I believe Seth Solomon's might be doing a session on that. Water quality and everything like that. So now that the session's over, we can the next session will be more not the next session, but next week will be more on how to do stormwater management design to get your ESTV provider and your IR provider for that. Alright. And that should be it for today. Does anybody have any questions whatsoever? Let me know.
Okay, Dev, this is Mahendra.
Yeah.
Remember, very important tool to measure the drainage area. When we click measure the drainage area, if the drainage area is in the ground with zero coordinate, not inclined, that gives the correct acreage of drainage area. But if it is inclined or in the different axis, it gives way bumped impervious area, right?
No, well, the drainage area should always be. Are you talking about like in a 3D or 2D file?
Yeah, we need to make sure it is not in the 2D. It is same dimension.
Right, yeah. So, yes, good question. So, the only file that should be 3D is
Hmm.
is the grading file.
Yeah, yeah.
None of your other files except for like the survey and grading should be 2D.
Okay, okay.
Okay.
Yep, that
If
answers
it's
my question. Yeah.
Yeah, because if it's in 3D, you'll have a hard time. It won't give you the area if it's in 3D. Because
Right. In my past experience, one of the engineer measured the drainage area. Somehow the drainage area was tilted, maybe a 3D or I don't know the axis. It was not 0, 0. It was maybe 1000 and 0. Just like a tilted, and even if it shows a small drainage area, if it is tilted, and we measure a huge drainage area, that's what happened.
yeah, so the reason that is because it's probably in a 3D file and it wasn't doing because when you measure drainage areas, we're doing it in acres and square feet, so it's not like cubic feet or anything like that
Yep.
in volume.
Yeah.
That's a good question. Yeah, 2D files are very easy to do. Which I'll go over like 2D files, 3D files next week in terms of like stormwater management design and grading for you guys
Right.
as well.
Right.
Uh,
Okay. That's good. Anybody, if you guys have any question, you can ask now. Okay. Even if you have a question after Dave presents, you can email him or you can call him and ask the question. Thank you, Dave, for organizing the second session. Tomorrow is our third session. So we'll see you tomorrow.
all right.
Thank you very much for presenting this nice presentation. It helps a lot. Thank you. Have a good day. Bye.
All right.
Thanks, David.
Yeah, thank you, everybody.
Thank
Thank
you.
you, David.
Thanks, Evan.